Using a dropper, put a drop of each of the samples used in Activity 2.1, one by one, on separate pieces of turmeric paper. Record your observations in Table 2.4. Table 2.4, Testing the nature of samples with turmeric paper. SNUM, name of the sample, the color of the turmeric paper after putting a drop of the sample. Record your observation. 1. Lemon juice. 2. Soap solution. 3. Amla juice. 4. What did you observe? Do all samples change the color of the turmeric paper? Group the samples which do not change the color of the turmeric paper. Compare them with the samples in Group A, Group B, and Group C in Table 2.2. Can turmeric paper be used as an indicator for acidic substances? Discuss your observations with your classmates. Based on the observations, we can conclude that turmeric paper can be used to test basic substances. However, it cannot differentiate between acidic and neutral substances. A student says, open quote, "I got a curry stain on my white shirt, and on applying soap it changed its color. Wow, now I know the reason." Fascinating facts. Why is turmeric known as a golden spice? Turmeric is a member of the ginger family, which is grown in India and other countries. A common spice in daily households, it is being researched for benefits beyond the taste and color it provides to food. In the Ayurvedic system of medicine, turmeric is considered to have numerous health benefits and is commonly used in several traditional home remedies. Ashwin created a greeting card to pay gratitude to his teacher on the day of Guru Purnima. He applied turmeric paste on white paper and dried it. He wrote his wishes in the teacher's mother tongue, Odia language, on the dried paper using one of the solutions tested in Table 2.4. Which solution can be used to write the message? His teacher applauded his creative use of this concept. A student asks, open quote, "Are there any substances whose odors change on adding acidic or basic substances?" Close quote. There are some substances whose odors change in an acidic or basic medium. These are called olfactory indicators. Let us explore more. Activity 2.6, let us investigate. Take some finely chopped onions in a container along with some strips of clean cotton cloth or filter paper. Tightly close the container and leave it overnight. Take 2 of the cotton cloth or filter paper strips from the container and check their odor. Keep them on a clean surface and put a few drops of tamarind water on one strip and a few drops of baking soda solution on the other. Allow the drops to spread on the strips. Check the odor again. Do you notice any change in the odor of the onion strips before and after putting tamarind water and baking soda solution on them? Note your observations. Similarly, test the change in the odor with other acidic and basic substances and record your observations. Know a scientist. Acharya Prafulla Chandra Ray, P.C. Ray, is known as the father of modern Indian chemistry. He earned a doctorate in chemistry from the United Kingdom and returned to India. He contributed towards advancing scientific research in India. He also established India's first pharmaceutical company, a company in the field of medicines, in 1901. He was a person rooted in Indian culture and knowledge traditions. Through his writings on the history of chemistry in India, he highlighted the achievements and expertise of ancient Indian scientists to the modern world. Ray, a social reformer, also advocated the use of the mother tongue as a medium of instruction in educational institutions. Number 2.2, what happens when acidic substances mix with basic substances? Let us investigate by performing the following experiment. Activity 2.7. Let us experiment. Take 1 drop of lemon juice in a test tube and add around 20 drops of water to it. Observe the color. Add 1 drop of blue litmus solution to it. Do you observe any color change? Fig 2.10a. Slowly add drops of lime water to this test tube with the help of a dropper and swirl it well. What do you observe? Is there any change in the color of the solution? A stage comes when the color of the solution changes from red to blue, figure 2.10b. Again, add 1 drop of lemon juice to the above solution. Can you predict why there is a change in color? Figure 2.1a, the color of the solution on adding blue litmus solution. Fig 2.10b, the color of the solution on adding lime water. Initially, when a drop of blue litmus solution is added to the lemon juice solution, the color of the solution turns red. When lime water is added to this test tube, the color of the solution eventually changes from red to blue. This shows that the solution in the test tube is no longer acidic. Lime water has neutralized the effect of the acid. When the solution of an acid is mixed with the solution of a base in sufficient quantity, the resulting solution is neither acidic nor basic. Such reactions are called neutralization reactions. In a neutralization reaction, salt and water are formed with the evolution-release of heat. Neutralization reaction: acid plus base, salt, water plus heat. There are many examples in everyday life where you can observe the use of neutralization processes. Number 2.3, neutralization in daily life. Situation 1: ant bite. Kirthi was observing a butterfly in the garden with her hand resting on a tree trunk. Suddenly, a red ant bit her, leaving her skin red with stinging pain. Figure 2.11. Her brother helped her by applying moist baking soda to the affected area, which relieved the pain. Why? When an ant bites, it injects an acidic liquid, formic acid, into the skin. The effect of the acid can be neutralized by rubbing moist baking soda, which is a base. What remedies do people use to treat ant bites in your region? Situation 2. Acidic soil. On the Farmers Portal, an online platform from the Department of Agriculture, Cooperation and Farmers Welfare, a farmer reported, open quote, "My plants are not growing well lately." Close quote. After discussion, it was found that excessive use of chemical fertilizers had made the soil acidic. Remedy: when the soil is too acidic, plants do not grow well. It can be treated with lime, which is a base, Fig 2.12. Figures: Fig 2.11, stinging effect of an ant bite. Fig 2.112, neutralizing the acidic nature of soil. If the soil is basic, organic matter like manure and composted leaves are added to it. Organic matter releases acids that neutralize the basic nature of the soil. Sometimes the soil may be neutral, but the plants growing in it may still show poor health, which can be due to the deficiency of nutrients in the soil. Situation 3. Ashwin's friend Gerbir stays near an industrial area. He shared with him that the fish population in his neighborhood lake was declining day by day. What do you think might be the cause? It may be due to factory waste being released into the lake. If the factory waste is acidic in nature, what could be done to save the fish in the lake? The factory waste can be neutralized by adding basic substances before releasing it into the lake. Let us wrap up. Now, can you explain why the words "Welcome to the wonderful world of science" appeared on Ashwin and Kirthi's paper sheets when the liquid was sprayed on them? Do you think that one possibility could be using a turmeric solution for the spraying liquid and a soap solution for writing on the paper? In a nutshell, substances around us may be classified as acidic, basic, and neutral in nature. Extracts of lichen, red rose, red hibiscus, purple cabbage, turmeric, etc. can be used to indicate the nature of substances. Substances that show different colors in acidic and basic solutions are called acid-base indicators. Acids turn blue litmus red. Bases turn red litmus blue. Red rose extract gives red color in acidic solutions and green color in basic solutions. The yellow color of turmeric turns red in basic solutions but remains unchanged in acidic and neutral solutions. An acid and a base neutralize each other, forming salt, water, and releasing heat. Many day-to-day problems like a red ant bite, acidic or basic soil, and industrial waste can be managed by the process of neutralization.